Welcome to Part 8 of the RevSim virtual coffee break. Today we'll be hearing a little bit more about the welding simulation, a case study from the Ohio Supercomputer Center from Alan Chalker. Also, you'll hear a little bit from Wolfgang Gentz of the UberCloud. This is Bob Farrell. I'm with RevSim.org, and just want to tell you briefly about that site. RevSim.org is an online community of volunteers who are interested in further the democratizing simulation initiative. We've come together to create this website, and it's chock full of information. If you go there, especially under resources, you'll find case studies under success stories. Under resources, you'll learn more about how it works. You'll see any of these videos that you may have missed along with others. And in the How It Works section, along with high performance computing, you can learn more about all the other disciplines that have to do with implementing and making a successful transition to democratizing simulation. So with that, I'm going to turn things over to Alan, and he'll jump into the case study.
Thanks, Bob. Want to talk a little bit about what we call virtual fabrication technology. So I think everybody is generally aware of welding and what's involved with welding, but there's an awful lot of sophisticated analysis and things that happen at a very, very high end of welding. So we have a client, EMC2, that is an expert in thermal and structural analysis and simulation. And they've developed a software app they call VFT, which again, Virtual Fabrication Technology, that allows non-experts and novices to do some simulation before they do their welds, in order to ensure that the parts that they're going to end up with meet the specs that they want. And the way that really works is it has to do with distortion. So what you're seeing here on the screen is a fixture holding in place some relatively large metal pieces. These are multiple feet long to 10 plus feet long, that need to be welded together. And you can imagine that as you weld something like this, you're heating it up in localized areas, and you're going to get various stresses and distortion and things like that. And you might have different types of metals that you're trying to join that can cause all kinds of weird structural stuff in the final product. So what happens as a result of this app is you can see the impact on the final geometry, on the final microstructure of the system. So on the left-hand side, the baseline case, when you're welding a big object like that, you might find that after you've done the weld, that bottom plate is distorted, because again, it's relatively thin, and you've got these big cross beams that are rigid, that are being attached to it. You're putting various beads of the metal weld down, and it changes the microstructure enough to cause a distortion, and as such, it's not flat. In the manufacturing industry, that often requires what's called rework, that you have to put the part back in and grind or bend or re-weld certain things. With the app, what the app will tell you is ways in which you can do what's called pre-cambering. So before you weld, when you set it up in that fixture, if you bend certain components out of alignment slightly while you're welding, the welding process we just talked about is going to do a certain amount of changing and altering to the structure. And basically, magically, when you're done welding, you remove it from the fixture, everything is going to pop into the correct place. So you're still having distortion, but by pre-distorting it in the opposite way, your distortion then brings it back into the final original shape that you really want to within spec. It's a way to avoid additional rework and costly changes that might happen afterwards. This can be used for a variety of products, variety of welding types, materials, things like that, and that's all kind of built into the app so that instead of doing a whole bunch of trial and error or being a real expert in modeling and simulation, we've helped democratize it here by making this app available with the EMC's knowledge on OSC's awesome platform to various manufacturers out there. So with that, let's turn it over to Wolfgang, who can talk a little bit more about the RevSim website.
Yeah, thank you very much, Alan. And we invite everybody cordially to join the Revolution in Simulation community. Whether you are a simulation consumer, so an engineer, scientist who has to do simulations, large and small, whether you are from academia, especially in the education space, using simulation to educate students, or being a student to use simulations for your further and future work. Be it industry analysts who forecast the trends we are moving on and provide feedback about the market, or the industry media like Digital Engineering, engineering.com, and other magazines which contain a lot of useful things about engineering simulations. Also the industry organizations like NAFEMS and ASES and others which regularly organize conferences, trainings, etc. And finally, last but not least, the simulation providers. These are usually, for example, the software providers who offer this very highly complex engineering scientific software. And you can join us, and we are a bunch of topic moderators, volunteers, executive sponsors, and we have a great website team. So you join us, and you can read a lot, you can work with us, you can do your webinars, and a lot more. Just go to our website, revsim.org, and on the next slide you see the links. You can register, or you can also contact directly Alan with the OSC or on our side to learn more about these case studies. And with that, on behalf of Bob and Alan and myself, thank you very much, and see you soon again with our next coffee break webinar.